Hey everyone, welcome to Community Call 57 from EthStaker and the community that we have here as well. I'm Jonathan, and welcome to the call. And we have a bunch of other people here to talk about validator gas limits and what that means for stakers and Ethereum broadly. And yeah, we tried to pull together a variety of people to talk about this that have good insights and experience thinking about it, from client devs to community members and the EthStaker crew as well. So I thank you all for joining. We have a number of people from execution layer teams and Paul from Teku. We have Simon, Ben, Sam from ETH Panda Ops. Thanks for joining, and Anthony too from Daily Gwei. Great to have you. So yeah, I think we can get into it. Just structurally, I mean, we'll do this kind of conversation for like an hour or so. But structurally, I think the way we want to talk about it is like understand from, a staker's perspective why this has been such a topic lately and kind of ground it for us to understand like how should we be thinking about this and what's really changing and is anything changing now? I think we all see like tweets out there that hey, we're going from 30 million to 36 to 45, and some of this was related, maybe Petra is enabling some of this, and where do we go in the future? So yeah, kind of setting the scene a little bit and then uh, understanding what's at our disposal and what we're enabling here by marching forward on increasing the gas limit, which it seems to be, the overall trend is that that's accelerating. So yeah, if that sounds good to everyone, we can jump into it. I think in terms of maybe like why does this matter? Like if anyone wants to take this, like why are we even talking about this? I guess just starting at like a simple uh starting point. Like, we know we have these settings and all kinds of levers in our uh staking machines. What like yeah, what is this enabling for us? Why are we even talking about this?
Maybe I can take a stab at the
Anthony,
high level, and then
yeah.
others can jump in on the more technical stuff, since they're obviously much more kind of in that kind of area of things. So
Yeah.
I guess like the highest level you can go is that, all else being equal, higher gas limit means more scalability for the layer one. And I think it's pretty important to make that distinction. That yes, it may offer some kind of scalability to layer twos, in that it could like make bridging cheaper between L1 and L2 and so on and so forth, but it's not like a direct thing. Obviously, with the L2s, we have the blobs. That's like the main thing that we're scaling for the L2s. Whereas the gas limit is pretty mostly like an L1 thing. So yeah, as I said, all else being equal, you get more scale. And what does that mean? You potentially get cheaper fees. But I think what maybe gets misconstrued a lot is that just because the gas limit goes up doesn't mean that the fees are going to stay the same. Like, let's say the fees are like 1 GWei at a 30 million gas limit, and then you double it. The fees could still be at 1 GWei, like, because demand could go up to match the increased gas limit. We've actually seen this happen over the years as we've increased the gas limit. So it doesn't necessarily mean that the fees are going to be lower following a gas limit increase, but it does increase the overall kind of scale of the L1 chain. But the trade-off is that it also makes the chain, I mean, not hard, like really hard to run or anything like that. It doesn't add too much overhead. But if we were to like 10x the gas limit today, for example, that would add a huge amount of overhead to the chain. It would probably kick off a bunch of solo and home stakers who have lower powered hardware. It might even send the chain into like offline, right? Things might just break, and that 100% uptime that we have would just go away. So while it is obviously something that we want to do as part of the larger kind of roadmap of scaling the L1 generally, which has become obviously a huge focus over the last 6 months, probably a bit longer than that. And it goes hand in hand with things like reducing slot times, which is reducing block times, I guess we say slot, but yeah, as the technical term there. So yeah, that's the kind of high level. But I think to cap that off as well, just for people who don't know, validators themselves, so people actually running the validator software, control the gas limit as a collective. So you running a validator can set your gas limit to pretty much whatever you want. And then once 50% of the network network has that kind of gas limit set. But, it doesn't have to be the same as yours, but like they come to a kind of consensus on what to increase the gas limit to, then the gas limit will slowly kind of rise from there. But yeah, I don't know how long that's going to be a thing. Maybe we don't always have like there's debates about this. Like, should validators be the ones in control of the limit, considering that most of them aren't going to be of the kind of like core dev level where they actually understand what it means, And I think typically in the past, what we've seen is that people won't act, especially the bigger operators. They're not going to act on their own. They're going to wait for the core devs to be like, yes, it's safe to do this. Like we saw recently, everyone was calling for 60 million gas limit. And then the core devs were like, well, it's probably not like the safest to go straight there. Let's go to 45 million first, and then some of the execution layer clients actually had the default change to 45 million, and then we can go to 60 million after that. So, in practice, I would say like I guess like in theory and in practice, sorry. Validators do control the gas limit, but then in reality, what ends up happening is that people just want to listen to the core developers because they don't want to break anything, obviously. So yeah, that I'll stop there.
Yeah, and that's great setup because I guess it's great that we have a number of core developers here. So maybe we can hear from you guys, like what is it that you're thinking about as you're recommending things to the community and Sam from ETH Panda Apps too. I know you have a number of insights about like how you guys analyze the data. I saw there's a link here. Oh, and by the way, there's going to be like a bunch of resources and links shared in this call. We've already got a bunch of them collected, and we'll be adding those to the recording that we'll put on the EthStaker YouTube channel because it's kind of a lot of like reference reading that you can go and kind of follow up on. So, but yeah, like
Yeah,
lots
I
of
can touch
resources
on
are
this.
developed around this.
Yeah. So the end result of like core developers suggesting a gas limit is like aggregated across the whole stack. So at the lowest level, we have the execution layer devs like Simon. They know, the technical, how fast can we process this block? And then we have the consensus layer with Paul and Teku, like how fast can we gossip this block? How fast can it get through the network? And then our side is how can we observe both of these things? Like we have home stakers contributing data to us. We go in there, analyze both of these things and sort of see what is, what's safe, what can we get away with? And then we sort of come to a conclusion of, yeah, it's there's multiple actual problems here, and we need to come with pretty much like come to a single number. Um, the result of the 45 million was actually from the Berlin to ROP about a month ago. And that process, as you mentioned before, Anthony, like we were originally at 60 million. We thought that was safe. But through a lot of the testing on the execution layer, we found that maybe it's not safe in the very, very worst case. So the recommendation changed to 45 million. Yeah, so it's sort of like an ongoing, evolving process that I think we're still sort of the muscle's still being trained. We haven't really done many gas limit changes over the last 3-4 years. So I think this little feedback loop of like collecting data, analyzing it, working with core devs to figure out what is safe. I think it's going to get a little faster because it's been pretty slow, I'd say. I think that's probably a bit of feedback that we've got from the community that it is painful to update these gas limits. So the whole process needs to be streamlined. And I think those things are sort of happening.
Yeah, because I know there was efforts like I remember maybe 6 to 12 months ago of, here's how you go and change it yourself, right? Like go in your
Yeah, it was
exec
Pump
start
the
line.
Gas
Yeah.
website. I think it was pumpthegas.org. Yeah, Eric Connor and Mariano Conti from the community created it.
Yeah.
I remember originally being against this at the time. I was like, I don't think we should do this. Yeah, there was those efforts there. But I think what Sam was saying about this being like a very kind of arduous process, right? Like, because it's you have to socially coordinate this. It's not something that, I mean, you can just like change the limits in the clients, but then people have to update their clients in order for that to have an effect. And the only way you could, I guess, potentially quote unquote force it is obviously with a hard fork, because then everyone has to update their clients, right? But I think there was a post a while ago from someone, I can't remember who it was. I don't know if it was a core developer or someone else that said that. Oh, I think it was from I can't remember his name right now, but I think it was basically saying that we should just do this programmatically, like have like a time and say, okay, every 3 months we increase it by X amount, maybe a small amount of the gas limit. And then if something breaks, we just go back and then we continuously collect that data as Sam was saying, and then run through that feedback loop a lot faster rather than what we do today. Because yeah, I mean, it does take too long. I agree with that point. I think the vast majority of the community also thinks that as well. And it becomes this thing that I just keep posting about on Twitter every couple of weeks. I'm like, hey, look, we're going up, guys. And it's like, we should already be at 45 million. Like realistically today, considering that the core developer said it was safe, we should already be there. And we're not there yet. We're almost there. But yeah, it does take too long, I think.
I can maybe just mention how the data on here is collected. So the way that the gas limit is actually changed is it's voted up or down for every block that's created. I think it's like 1/1000th of the actual previous gas limit, something like that. So to actually push it up, you need more than 50% of the blocks to have a higher gas limit. So that has historically made it pretty hard to know what people are signaling, because you don't know what people have set until they've proposed a block. You get the signal like they want it to go up or they want it to go down. Fortunately, we have a nice property of MEV boost and MEV relays, where as a part of that registration process for validators, they have to submit their desired gas limit. And that's not just an up or down, that's like the exact limit that they want, their target. So we're able to hit the relays and check what each validator across the whole set actually wants. So it actually gives us a pretty nice way. It's a nice property that we didn't really think of. But yeah, it allows us to make this site like Tony has, that gives us a pretty good overview of where we're at.
So is the upper chart using the MEV boost validators just trending it, or is it like the block
Yeah, it
proposals?
will be.
Okay.
Yep.
Okay.
It'll be using MEV boost, yeah.
Okay. So it definitely seems, do you guys have any idea where these came from? Like this seems like around July 9th. There was a pretty stair-step process down here from some set of validators, but
I
um,
think around that point, clients started changing their default gas limit to 45 million. There's
okay.
also been some like coordination with some of the bigger entities. I'm not sure if this site has it, of like a breakdown per entity, but that will also be contributing.
Yeah.
I think we have a
There's
question
an
from
element of,
YouTube.
oh, go ahead.
So the question is, the gas limit increase could remind folk of the big block debate with Bitcoin that resulted in the Bitcoin Cash hard fork. Can you discuss why that would not be a concern here?
I mean, that's kind of why it's done on validator voting. So people are voting whether they want it higher or lower. So it's not like a hard fork that's forcing this. It's validators expressing, or previously miners, expressing where they want it to go. So it's like a democracy almost. Um, and I mean that could be seen, the switch from miners to validators, since they're two different independent groups, could also be seen as, why we got stuck for a while at 30 million. Because the move from 30 million to 36 million was the first increase where the people deciding the gas limit were the validators, and no gas limit had increased since the merge. So that was the um, first change that had happened with this different group.
Mm-hmm. And just to add to that as well, I think, Bitcoin and Ethereum are fundamentally different. The Bitcoin network does really nothing, especially at the time in 2017. Like I know now there are some things you can do, like some very limited NFT things and stuff like that. But back in 2017, yeah, I mean, like it exists only to secure the BTC asset. And that's what Bitcoiners want, right? They don't want it to do anything else, at least the vast majority. There are some that obviously are trying to make changes, but that's completely different to Ethereum. Like Ethereum is all about the network as much as it is about the asset. And the Ethereum network was specifically made to be able to do more. And if you want to do more, you obviously need to scale as well. So for Bitcoin, like, they deny things like the fear of a new kind of security budget crisis that's going to hit, like probably longer term, but like they don't like to talk about that. But that's the main drawback of what they're doing, which is essentially them saying, well, the Bitcoin network only exists to secure the BTC asset, so we actually don't need any activity on the Bitcoin network. It's there. Miners get paid, miners secure the network. It's fine. Long term, as I said, like that actually is an issue. So they don't really care about that there. But Ethereum is very different. I think obviously Ethereum is an expressive platform. We need to scale that, and yeah, I just don't see something like that happening in Ethereum where we have a block size war, so to speak. But Ben's point is also, very good about like the fact that it's more of a democracy rather than being forced top down. But it does have its drawbacks. It's slower. We would like things to move faster.
So, I mean, maybe that's a good segue into like where does it go from here? Because yeah, Ethereum is like constantly evolving to meet this kind of direction and like what the demand is from, the world to Ethereum to be what it's going to be and what it is. And so I guess like how what are the efforts? I mean, it's great we have a number of resources here around execution layer client teams and other core devs. And I guess what would you guys say about how we're proceeding for these future increases and like how we're doing that safely too? Maybe that's also a Sam question. Um,
So so 36 million was seen as, so the recommendations from the core devs are based on worst cases. They're not based on the average performance or the best performance of the network. They're like, what if there was an attacker? Because Ethereum has been attacked before, like there was Shanghai DDoS and there were all these problems, some of which were solved by client diversity at the time, where you had multiple clients, so it would take down Geth or it would take down parity, but not both at the same time, which helped with the 100% uptime. But so we're constantly looking for what are the worst case, what could an attacker do to try and take down Ethereum, and that's like the bound for the gas limit that comes as recommendations from the core devs. So the 36 million pre-picture was because it was realized that you could create blocks if you filled them completely with zero data. That would be too big for the network to propagate. So that was seen as like, that's the safe. And then in Pectra, there was a call data increase. And that allowed, that removed that as a potential attack. And that's why we can go much higher now. And so the recommendation is 45. It was 60, but it was felt there are a few edge cases that would be problematic for weaker validators. So there are improvements coming in Fusaka to remove that, and potentially before that, client improvements to bring 60 million back on the table. We'll see how that goes.
I think there was an important unlock that happened as well with the hardware and bandwidth requirements EIP, EIP 7870, because that kind of gave an expectation of like some idea of like what you should aim for to run an Ethereum node with different types of nodes, and enable us to have a benchmarking target as well, which lets us do some of this testing and be able to say like aim for a certain throughput against that hardware. So I think that's been an important step as well that happened early on.
I think one of the things that we as core devs do sometimes is we throw stones at things. So we have a look at what all the settings are now, and we try and break them. That's just part of what we do. So um, that happened a lot in Berlin, and it was really, really cool to see all of the execution layer devs try and make things faster and specifically remove limitations that we have. And that's also what fed into the 36 million gas target, was that there were issues on the consensus side. So it's kind of cool to have a job that where a big part of it is breaking things sometimes. That's what the pandas offer too, is that they do a bunch of work to enable us to have large networks that we can effectively break without breaking actual mainnet or anything like that, which is obviously a goal to not do.
I'm just showing the state of current mainnet. I don't know whether is visible on YouTube. This is the visualization I came up with on talking to members of the Daily Grey. And just to see, rather than, the idea is as a solo staker, well, as if you're running a node, normally the way you find out what your node is doing, you have to like set up Grafana, or you have to set up loads of other tools that then monitor your node. And the idea was, well, maybe you could just have your node server user interface. So as a solo staker, it becomes much easier. So this is what mainnet's doing. These are, in the latest block, it's showing you all the transaction sizes, and then showing you how much space is free in the block. And here's the gas target. Although what we're talking about, which is 50% of the gas limit, which is what we're talking about. So this is currently 36 million, the limit up here. This is the transaction pools. And here in the logs, you can see people voting up or people voting down. So you can see this is the gas limit changing here. And these are transactions that happen in the block. But you can see, so some of the future changes that we're working on is if you see how much time is spent on actually validating a block, it's actually quite small. So there is a lot of slack in the system, but changes are needed to do things like restructure the slot, to give more time to the execution, and various other things, which are in future proposed EIPs.
And as Ben showed there, yeah, like a lot of the blocks are like a small number of milliseconds to process. But if you were to get one of the worst cases happen, maybe like an attack happened, then that number would go up and you'd get into like the danger zone of like 3 or 4 seconds, and then that starts impacting the network then.
Yeah, this is pretty cool. I mean, it's always enjoy seeing kind of like the living, breathing, like what does your node look like if you kind of visualize everything going on in there. Um, I mean, the closest thing I can think of is like a Grafana dashboard to see something like this. So, but this is even more involved in kind of analyzing what it means for Ethereum and from your node. So that's cool. So yeah, maybe just a practical question. Like if I imagine like as a staker, if things are progressing and all of a sudden the gas limit's gone up to like say 100 million, maybe this is in not the too distant future or something. Practically speaking, for me as a staker, like I guess I would have had already the opportunity to update my client software, right? And should be compatible with it. But is there a compatibility concern, or like what happens if you don't update that? Or is this like another type of like you got to update your software or else you're left behind or something? I don't think it's a hard fork scenario at all, but um, like correct my understanding, I guess. Like what, and just thinking about like short-term changes, like what might happen in the next, 3 months if that were to happen. Does that question make sense?
Does to me. I think what you're looking at potentially, well, 100 million is a hard fork, right? That's after Fusaka with repricing. 60 million, if that's deemed safe before Fusaka, as I understand it, that might require an update by a validator node operator because it becomes safe with potentially a new release that is faster. And so it doesn't have the worst case bottlenecks that have been identified.
And so let's say it's the other way around too. Like let's say the network is kind of signaling that you can go to 60 million or something, but I say, well, for my validator, I'm gonna hold it back to 45 or whatever, for whatever reason. Is that going to be a detriment to like my
No,
my
you're
staking nodes?
voting up, you're voting down, right?
Yeah.
So there's no such thing as I'm holding it back to 45 for my validator. The best you can do is decrease it by one thousand and 24th compared to the previous block, right? That's the voting mechanism.
Yeah.
So up by 1,024th or down by 1,024th. So once the network has decided that 60 million is safe and it's there, that's potentially what your validator has to handle when it's proposing a block, right?
Yeah, and I think that's important. Like if a certain percentage of the network can no longer keep up, what would start to happen is that, we might get down to a point where we lose finality. So then we could have time to adjust things like be installing updates to clients or anything like that. But as clients can't keep up anymore, we'll lose finality eventually if that was to happen, for example.
Right. So previous to this call, we discussed a little bit of the vision, right? Like what is Ethereum actually trying to get to? Can we show the graphic we have for that vision? That one. Yeah. So if that's okay to share, this is incredibly aggressive, right? We're looking at 3x per year. So when you look at this here, 100 MGAS, I'll step back and say this is hugely optimistic, right? But 100 MGAS this year, 300 next year, 900 after that. Eventually with ZK, we're getting to ludicrous amounts. Yeah, exactly. Research life. Incredibly optimistic things. And we just had the blog post from EF that said we want to see provers on mainnet sooner rather than later so we can get experience with it. We want pipelining in Glamsterdam, whether that's EPBS or delayed execution, I think is to be determined, so that we have 9 to 10 seconds in the slot to do a proof. And in the meanwhile, we're pushing here for gas. Maybe I can ask the first question. What is Ethereum L1 trying to accomplish here? Why are we motoring towards, what is it, 24.3 gigagas by 2030? Again, taken with a huge heap of salt, that date.
Well, it's the base financial layer for the and not necessarily just financial for the entire world. So if you think of every transaction in the world, even that won't be enough. So we will also need. So this is vertically scaling where L1 gets more and more capacity, but we will need to horizontally scale, which is the L2s, so that then so that it's even the total Ethereum ecosystem is much bigger than that. So if you think like for instance, decentralized social media, if that probably wouldn't happen on L1 because, it's not, I don't think it would be financially sensible. But, Base has just said that they're doing um, something there, and also there's Podcaster, for instance. Um, but if you're doing all that sort of stuff, those levels of transactions are pretty high, and so you'd want even more than this level.
Yeah, and I think at just a high level here, scaling the L1 is just good in general, right? Like scaling the change is good in general. It's good for everyone. It's good for both L1 users and L2 users and L1 developers and L2 developers and everyone, right? Like there's no like drawback to scaling the L1 in terms of negatives for like users, for developers. But obviously it has to be done in a balanced way where we preserve what actually makes Ethereum valuable as a ecosystem, as a network. And I think this is where a lot of the contention lies. Maybe it's a good kind of segue into talking about the contention here and like maybe why we haven't done this as much in the past, why people were hesitant to do this, why we do it slowly. And it really is to preserve the number one, at least in my opinion, the number one priority of Ethereum is to preserve decentralization, right? And everything that kind of entails there, because there is a spectrum here. I don't believe that decentralization is a spectrum like broadly, but there is a spectrum of like, I guess you could call them node requirements or validator requirements that either put you into something that is pretty much centralized or like very, very decentralized. I think that the middle, I don't really think there's a middle. Like people will argue that there's a middle there because they say, it's a spectrum and then there's a middle where some things fit. I don't necessarily think that's true. I think, other ecosystems may want that to be true because it makes them look better. But I think in Ethereum, we've always obviously tried to be at the, fully decentralized kind of side of things. But you don't get that for nothing. And that's why Ethereum L1 has historically remained the way it is. Like, it's much less scalable than some of these other chains out there. But that's because these chains run in data centers, right? Ethereum L1, yes, there may be validators in data centers and things like that. But Ethereum L1 has a very strong, or Ethereum as an ecosystem, I should say, has a very strong home staker, home validator, home node runner ecosystem, like incredibly strong. I mean, there are thousands of us out there, and all these other chains don't even have thousands of active validators, right? Like just generally, they usually have hundreds, if not tens, whereas we have thousands. I should say node operators, not validators, is the correct terminology here, of home node operators here, and that is one of the reasons why Ethereum is truly decentralized. But if we were to crank the gas limit up 10x today, we would lose a lot of those players. We would potentially break the network as well, as I mentioned before. And then going even higher, as seen on the graphic, would just be even worse. But in saying all of that, as I said before, over the last 6 months, there's been a renewed kind of priority put on L1 scaling generally. And there's a lot of things kind of coming out of this. There's a lot of things coming that we didn't know before. We're kind of looking into this and we're being like, okay, well, we can actually do this. We can actually do that. Yes, it has to be slow, but we can do it. And we want to make sure that we prioritize that decentralization while doing all of it. So yeah, today we could basically up the gas limit by whatever, to whatever we wanted. We would probably kick everyone off except the node operators in data center chains. We would centralize Ethereum, but hey, yay, scale. No, we don't want to do that, right? Like that's the thing number one that we don't want to do. So yeah, that's why it's typically been, I think, an arduous process, and something that's taken longer than people would hope. And I see on the screen here, you have that EIP that talked about validator requirements. And this was another big thing. I'll let someone else talk to this, but just to give the high level context, like traditionally we haven't had this. We didn't really have, we had like a soft, I guess, rule that, hey, we should be able to run these things on Raspberry Pis, but we didn't like define anything, strictly. It was just like, yeah, that would be nice to do. But once you have more strict requirements, then you have targets that you can go to, right? And there's no need to kind of be in no man's land of, oh, if we do this, we're going to kick off like the lowest powered node and it's some Raspberry Pi that's been running with 1 terabyte of SSD somehow, right? Whereas you start strictly defining things and yeah, you get a better sense of things. And it obviously gives the core developers and researchers better ways to target this and better ways to upgrade this.
Yeah, and I'm kind of curious to hear from like a technical perspective on like how this fits to like support everything that you're saying, Anthony, because I guess like when we go to something like, DevCon or DevConnect later this year and talk to people who are interested in being node operators, like we kind of go in with a conversation of, okay, like this is the hardware. It's, you can do it from home. It's, you need this kind of hard drive and this kind of memory. And so this is like definitely more detailed, some of this than what we start off with in those kinds of conversations, but it's also hitting on those same core parts. And it all fits together with like maintaining that decentralized network that we're striving for that's also scaling. So I guess I'm curious, like from the dev perspective, how this was constructed and thought of to satisfy all that.
I really like this page because for a long time I went into Cordev discussions saying, oh, but for homestakers, blah, blah, blah. And there was really nothing concrete to say, hey, we're impacting people on this metric. And what this page does is kind of defines what's a reasonable expectation for a home operator. And we can use that as an actual bound to say, we don't want to have silly low requirements for memory and all of that sort of thing. So I've found this really empowering to go into the discussions with core devs. As an Australian, we have not great internet. We have easy access to hardware, but internet is a problem. So, we can focus on those sorts of things and have actual informed discussions rather than just use pie in the sky. I think at one stage on Twitter, people were talking about a validator in a field somewhere and things like this, which is actually not helpful to the discussion. So this has been really empowering to have something to focus on.
I actually want to. Oh, sorry. I was just going to say on the bandwidth stuff, like this is actually at the heart of it, to be honest. And I forgot to mention this before. As Paul said, like if you have the worst internet in the world, you likely have access to some of the best hardware in the world because bandwidth is like across the globe is not evenly distributed, right? It is very different depending on where you live, which is crazy. I mean, last year I went to Berlin in Germany and my internet was just absolutely crazy. I'm like, why is it so bad? Like, why? Like I expected it to be better, but it was just so bad. It was so spotty. It was just terrible. And as Paul said, in Australia, where I am as well, like I've got really good internet where I am, but then someone, next suburb over may have really bad internet because the rollout of the fiber network in Australia was politically a shit show, for lack of a better term, and it resulted in this kind of inequality in bandwidth. So that's a big thing. It's like we have to, bandwidth is probably the number one thing that the core developers and researchers look at with regards to this, because you can get the best hardware, but you're limited by your bandwidth. You can't you can move to get better bandwidth, but it's not like you can force it where you are. Whereas with hardware, you can go buy the most powerful machine ever, but you're still limited by what you got access to wherever you are in the world.
So, good point there, Sassel. On the bandwidth thing, particularly the upload bandwidth, that's quite constrained in some places in the world, particularly, in the US. You look at US people, they sometimes can't get faster than 30 megabit per second up. Some even less than that, 25, 20, right? In large cities, it's pretty mad. This is why I'm really excited for ePBS. I know that it's not a chosen headliner. We'll see that in the coming weeks, whether it will be. That's the enshrined payload block separation, which gives us 9 seconds to get everything done rather than the 1 to 2 we have right now, which means that even if you build locally and you have to get all these blobs out there, which is the largest part, that's the part that's hard if you build locally and you ship blobs, right? Lots of momentum on ePBS, exactly. I'm hyped for it. It really helps homestakers, is what I'm saying, because it gives us that 9 seconds to smooth out that upload bandwidth, right? Now, if I read the blog post that EF brought out, I think this week or last, about ZK EVM and moving to ZK proofs and wanting some form of pipelining, which ePBS is one of those in Amsterdam, then I potentially see a different path from what Sassel is seeing. I do see us being decentralized in some ways and centralized in others. We're already centralized for block building, let's face it, right? There's a couple people building locally, but over 90% of the blocks get built by the big builders, and that's not going to change. I think that's here to stay. If we're going to proving, then we'll still have home stakers. We need them for stuff like FOSL, like folk choice inclusion lists, right? If we want to make sure that we have honest actors, we need lots of them. But the provers themselves, I think the idea is that people could still home prove, but certainly not on a little knock, right? Where the current the current target is, and that's an ambitious one because real-time proving is hard, is $100,000 of hardware with 10 kilowatts of power that it draws. Good God, I hope you're not vacuuming in your home when that thing runs. You know?
This is a good point, I think, as well. Something that I forgot to mention before is this kind of separation of roles that have been forced on the network. It's not something that I guess like the researchers or core developers came up with themselves. It's that today, 95+% of the network runs MEV boost, right? Which feeds through I think 2 or 3 top builders that make most of the blocks. So if that's the reality, and if that's something that's unavoidable, how do we work around that? And that's where things like Fossil came from, because really it's not like a huge deal, for decentralization. I don't think. Like, I think the huge deal becomes over censorship resistance, because we saw this with the OFAC sanctions on Tornado Cash, where essentially, because you've only got these small group of builders, they could censor like massively. Like, yes, you have like all these different node operators, thousands of them, that would have to individually censor. But when it comes to builders, if everyone's just going through like 5 builders, right? 5 builders build 95% plus of blocks, then it only takes 5 entities to censor, transactions for long periods of time. Get 100% censorship on the network is pretty much impossible, I think, today. There'll always be someone willing to include your transaction for cypherpunk reasons. I'm one of those people, but I only propose a block every so often. Like, it's not like it all the time. So yeah, there's a validator concentration of things, obviously, with big staking operations like Coinbase and obviously Lido as a collective and Binance and things like that. But then there's the centralization of building, and as Thorsten mentioned, proving in the future as well. But we offset this with things like Fossil, which improves censorship resistance, which is like black magic to me. The first time I saw it, I'm like, how does this work so well? And people who came up with this are much smarter than I am. And then liveness is the other thing as well. It's like, okay, if there's only 5 builders, how much liveness do you have on the network? Can you fall back to validators building their own blocks? Today you can, like the individual node operators building their own blocks instead of building it through MEV boost. But in the future, maybe this isn't very possible for most node operators because of what Thorsten was mentioning about this, about proving and about kind of like requirements going up. So there's a delicate balance here. I'm personally not too concerned about it, given that we are offsetting the trade-offs with other things like Fossil. Like, it's all about the trade-offs, right? It's all about balancing those. But yeah, it is something of an active discussion.
Yeah, and so talking of trade-offs, right? That EIP we showed earlier, the hardware EIP, it gives a spec that gives us room to the upside. So if you think about the current builds, they're typically 4 cores, 8 threads, 32 gig of RAM, maybe a 2 terabyte NVMe. Those can run validators or run a node with even hundreds of validators with room to spare on the upside. This EIP doubles that again. 8 cores, that's 16 threads in Intel land, 64 gig of RAM, 4 terabyte NVMe. Not something the network currently uses in any way, shape, or form. But it does give that optionality of saying, we don't know what we're putting into the network after Glamsterdam or with Glamsterdam, right? That's not even decided yet. So we want to give people something where we say, if you run this, then, for the foreseeable future, that should work as a home or, a solo staking node. Where I'm really interested, as we're moving this multi-year into the ZK future, is we're going right back to validating on something tiny. Potentially even, I don't know, I mean, it's stupid to do it on a phone, but potentially even something as constricted as a phone. Because if you're not executing anymore, if all you're doing is verifying a ZK proof, that's incredibly cheap. The verification is cheap. Creating the proof is really hard. Yeah, there you go. Raspberry Pi. I don't think we're going back there, but maybe eventually, once we're in ZK land, who knows?
This
Yeah,
is
the verification, stuff is the through line here, I think. Yeah. Cheap to verify, but to actually, prove the thing and do the actual like hard work is not cheap. It's probably not going to be like cheap enough for most home users for a long time. Maybe we eventually get there. Like obviously like technology evolves and things like that. But then maybe we say, well, we want to scale even more. And then we start throwing, more kind of power at it, more hardware at it.
Yeah. I'm not going to go into VPUs and all that kind of stuff. We're already far afield. I think if I want to bring it back to the hype, 2026 with 300 million gas, that's the target Vitalik laid out. This one, right? 300 M gas. That's the target Vitalik laid out, the 10x target to be able to come out of a failed layer 2. So if we really can get that done next year, I think that's exciting. So there's a blog post he did, I think in 24, where he said, imagine a layer 2 fails, either maliciously or not. People need to get out within, say, 30 days, right? They need to get all their assets out. They can trustlessly, permissionlessly bridge them out. But does layer 1 actually have the gas to do that at a reasonable cost? And the answer is no, it don't. Not for a well-used layer 2 with, say, 100 million users, right? Yeah, that one. Exactly. So he does a bunch of math and he says roughly 10x from where we are now, that was 30 million, I think, at the time, gets us to where we don't have to worry about that and we can come out of a layer 2 if things go horribly haywire. So I like having that safety net that quickly. And then, the mad scaling up to gigagas per second. We'll see whether that happens and how fast, but I'm here for it.
I think going back to the hardware requirements, there's a interesting side note on the storage being set as 4 terabytes. I think that was done because the history expiry roadmap was kind of in question. But we've actually, that's ready now. So like the latest versions of clients, I think, all have some form of history expiry. So that kind of keeps things well under 2 terabytes for now. And there is a roadmap to reduce it to a rolling window of history expiry, which I'm hopeful will be this year. I don't know that for sure. But that would bring the chain data storage requirements, which at the moment is the dominant factor. That would bring it right down, and then state would be the dominant factor, world state on disk. And I think there was some research from Paradigm. I think they said it in 5 years. There was a prediction that it could be like up to 600 gig of storage total. So even that's you're
For
still
state.
within the 2 terabytes for state. Yeah.
So thank you for that segue. So we're not going to get into history expiring in depth here, but in the past it was always we can't raise the gas crazily because state growth. Where are we going to store all that? So if we really go to 300 million gas in 2026, 900 million gas in 2027, and so on, or let's assume a slower pace of that, but with gig gas or even gig gas per second eventually, what does that do to state growth? I don't think anybody's talking about state expiry, are they?
So a part of there's been a number of new initiatives in the Ethereum core devland of perf-nets, and one of them is to explore, how fast we can go, how, what are all to identify all the bottlenecks in the clients so we can fix those. And another one is called bloatnet. And the idea there is to take mainnet and amplify its state like 3 or 4 times, and then see what impact that has, because there may be other issues from that. So it's being looked into at the moment, what issues that would cause. I don't think state expiry, there are proposals for it, but I don't think it's necessarily, it's a complex thing. I don't think it's on the roadmap at the moment. Well, yeah, I think it's on the giant roadmap of all of Vitalik's. Here's all the amazing
Vitalik's
things they
big
can do.
roadmap, yes. Yeah,
Yes.
from the outside looking in, what it feels like is that in the past, there was maybe some fear around what do we do around history, what do we do around state if we really bump the gas. We can't afford to bump the gas because, then state grows. And now it's more, well, we have leeway, we have runway. Let's carefully investigate, let's scale, let's bump the gas up aggressively, but also investigate what that means, investigate what that means for the network, and adjust as we go. I like that less timid approach better.
Going back to the multi-cores, one of the proposals that's a little bit related to state growth, state, is block level access list. And the idea here is you would include with the block state that gets accessed, and also the post state. And this would enable all the transactions in a block to be run in parallel, all the storage access be run in parallel. So potentially that's a huge uplift in performance, and also it would use those cores. But also one of the things this introduces is sort of a path, an exploration into statelessness, because what if you included the state as part of the blocks, the state that's changing? And this sort of explores that, because it's providing sort of half of that in the block. So statelessness validation, where you don't actually need the state, could be one of the paths as well. Although it does potentially centralize the state a little bit, because builders would need RPC nodes and things.
Yeah, so RPC nodes builders still need state, but maybe not every validator, every home node needs state eventually, right? Right now it certainly does, but it doesn't need history. So, Jonathan, I'm sorry, we got here and there and somewhere. Where are we on the agenda and for time?
We're kind of like wherever we want to go, to be honest. I think we've covered a lot of what we kind of had planned, and understanding the future is kind of this nebulous thing that I think definitely can take a lot of paths. But I mean, it's interesting. I feel like I was expecting maybe there to be some, like, how much disagreement do you guys feel like there is among even this group here in terms of like how much we should be accelerating or not accelerating? I think it's almost kind of like a meme, like accelerating the gas, but then you bring it to the technical discussion. You guys are also balanced and nuanced about this discussion that it's.
I mean, one of the questions is, what would it mean for bandwidth, hardware requirements, and so forth. So a lot of the changes, the EIPs that are being done, is to try and so like a different network like Solana, they're just like, oh, whack up the the maximum, just increase the bandwidth you need constantly, and so forth, just brute force it. Whereas in Ethereum, we're making EIPs and so forth that change the structure, so it means that the requirements aren't going up. We can increase throughput using the same resources by changing how things work. So I mean, in the in the far future, when everybody has 10 gigabit networks to their home, perhaps that'll change. But certainly a lot of these changes we're doing increase. So to get to, where is it? To get to this post Amsterdam, like EPBS, for instance, for increasing the blob limit shouldn't increase the bandwidth you need, because it's now how it's being done is being increased intelligently, in such a way that the new blobs, if it goes up to 72 blobs, that's still using the same bandwidth as like 9 blobs now, for example. So it's there's a lot of research that goes into it to how to achieve more with the same, if that makes sense.
It absolutely does. Yeah, contribute data. Let's talk about that, and then maybe we can come back to the YT question from YouTube, which we have answered, but we can still ask it, I think. Let's talk about this data contribution though.
Yeah, I can touch on this. So a big part of safely raising the gas limit is getting data from the most sensitive users, and that's home stakers, for all the previous reasons that we've talked about in the last hour, like bandwidth being the large one, but also hardware. And the best way for us to get this data is via this contributor scheme that we've got. It's a sidecar that runs next to your node. So if you're a home staker, you can go to this link. There's a quick little form in there that just gets some details on you, and then we'll reach out with credentials and how to set this up. This level of visibility, I don't think any other network really does. We're really lucky in Ethereum that we have such a culture of openness and collaboration and stuff like that, because it really enables this tight little feedback loop that no one else has. I think it's a real strength that we've only sort of unlocked in the last 6 to 9 months. And I think especially with Fusaka, with PeerDAS, and as we're starting to pick the values for that, we'll see the first iteration where this is put to use. But the end result is we still want more data. So I think we've got 100 people in there at the moment, maybe 150 nodes. It's really, really valuable. It's really cool. If you do contribute your data as well, could you click the lab link in the top right, please, Ben? You'll see your node show up on the lab. Yeah. If you go Zatu, yeah, you'll see it in here. There's actually, I'll link there's a live slot view. Sorry, let me just grab that. Yeah, it's really important that all countries sort of contribute this data as well. So there's a couple Australians in there like us. I think Simon's in there as well, maybe Paul. If you contribute your data, you'll show up here, and it's really cool to see your node processing blocks, how you saw it compared to everyone else, if you saw it first, for example. And also one of the things that I've found really cool is if I propose a block, going on there and viewing that slot in this page and going, oh, how did this actually land around the world? Yeah, so quick little shout out there. Fill out the form, we'll be in contact. Yeah, also to all the people that have been contributing, I'm sure there's people watching this stream at the moment. We really, really appreciate it. It's invaluable. So yeah, thank you.
So I'm assuming you particularly want this on mainnet, but does that also exist on Hudi?
Yeah, yep. Mainnet, obviously the main focus, but it does support Sepolia, Hudi, and Hosky as well. I don't think we actually show Hudi data on here yet, maybe, but we are capturing it.
Awesome. So maybe
And for anyone wondering,
Right.
this is the same as contributor, however you want to say it, which we've talked about before from EthStaker, and help, wanting to help get people contributing data for this, I can attest it's pretty easy to set up. So yeah.
Yeah, it's pretty simple. And some of the automation frameworks also have it built in, like it's built into EthDocker. I'm not sure whether it's in EthWizard, Remy can say. So
Not yet.
it shouldn't be, not yet, but soon, right? Shouldn't be hard. Can we take that question from YT? And I'm wondering, we touched on this before. I'll say what the question is in a minute, but I'm wondering whether we can do a lightning round. Everybody just saying what they think about it. So here's the question. Maybe this was answered. It was, but briefly. Why does the gas limit need to be increased? Gas prices are low. Is this unnecessarily squeezing stakers? So this is basically saying, what are we doing? Why are we scaling L1? Why is that a worthwhile thing to do and focus on? And I don't know, Jonathan, what do you think? Is a lightning round a good idea? Everybody giving their take? Because I
Yeah,
think we'll have a lot of different takes.
Yeah, I think that'd be good because I think this is a good question to kind of like piece that together. You go and look at the gas right now being super low all the time. Who knows if that may change, but like, how does this is this a cause effect with that? Does this? Yeah, I think that's a good question if we want to go around. We don't necessarily have an order, but how about Simon? I'll just go through this list I have here.
Yeah, I'll keep it short. Mainstream adoption, I think, is the biggest driving factor if we want to support the world's transactions. We need to scale.
Okay. I guess like the way I would also ask it is like, is this like trying to preempt the gas rising? Like how does someone think about that with gas being low right now? It went down whenever all the L2s started being able to submit blobs and all that. Like, yeah, like is this how do you reconcile the low gas with what we're pushing for here with a higher gas limit? Like, is this a logical? Yeah, does that question make sense? I guess like.
Yeah, I mean, I can jump in here.
Yeah.
I mean, like, this is like asking why are we going to scale the internet when there's only like a few thousand internet users, right? Like, you scale things because you expect things to grow. Like, we're obviously all expecting Ethereum to keep growing. So if we expect it to keep growing, then we need to scale it. Like, it's as simple as that. And just because prices are low today doesn't mean they're going to remain that way forever. And I would argue that even at the relatively low gas prices we have today, it's still pricing out a huge lot of people, right? Like, even if it only costs you, 50 cents to send ETH or tokens on L1, that's still pricing out like a lot of people, right? But then, there are arguments to be made around the fact that, well, if what you're doing on L1 requires L1 security, then you should be, you should have to pay for it. I'm like, yes and no. Like, I vibe with that argument to an extent, but then at the same time, I'm like, well, what if we can scale up Ethereum L1 security guarantees to as many people as possible by bringing costs down, right? What if instead of a 50-cent cost, it's a 10-cent cost and you get the same, you don't trade off anything and you get like the same guarantees. So that's the kind of way I think about it. But yeah, as I said, like the simplest answer is just that we're expecting Ethereum to grow both at L1 and at the L2s. So let's scale both. I think obviously over the past couple of years, most of the focus was on the L2s and not enough focus was on L1. But now it's part of the three pillars, right? Scale L1, scale blobs, improve user experience. And they all feed off of each other. Like scaling the L1 obviously improves user experience, right? Because user experience is about fees. And if we shorten slot times as well, faster transactions, stuff like that, right? So that's the way I kind of look at it.
Cool.
But I think you're right, Jonathan, that there might be a bit of a balance. Like we're focused on scaling the L1 for now, but like that may not necessarily be the case. In a couple of years or something. I guess it kind of depends. As the adoption happens, like we'll adjust, I guess.
Yeah, and it depends who adopts each kind of layer as well, I should say, right? Like you have L1 that may have more users that are obviously fee insensitive, right? And they're happy to pay those higher fees and they're always driving the fees up bigger entities like TradFi institutions, things like that. And then you have L2s that, some of them specialize in things like there's a gaming L2, right? That's got basically free transactions, but you're not getting anywhere near the level of security you get from the L1, right? From the Ethereum L1. But that's okay because it's just like some gaming NFTs that aren't really worth very much, but you need them for your game. Whereas with L1 Ethereum, like you have ETH secured obviously by L1 Ethereum, as well as things like BlackRock's putting their build fund on there, stuff like that, right? So different trade-offs, like it's all trade-offs. So you keep looking underneath and it's like trade-offs all the way down. You can never get around that. But that's what I think the Ethereum ecosystem does well, is that we balance those trade-offs. It may seem frustrating for people on the outside watching this, being like, why can't you just 10x the gas limit? Why can't you just bring the fees down? And it's frustrating for someone like me who tries to educate the wider kind of ecosystem about this. But yeah, if you look underneath, you actually see the logic.
I mean,
One,
the hope is
go on, Ben.
increasing the gas while it brings down the fees, because it allows the number of transactions to also grow. In aggregate, there would be more burn, more validator rewards, because for every individual transaction you pay less, but in aggregate, there's more GDP, as it were, happening. There's more activity. Also, as a contentious viewpoint, scaling the L1 in a way keeps L2s honest. They can't just coast on the fact that L1 performs badly, so they get free transactions. As L1 scales up, they have to keep putting the work in to improve their L2 to differentiate and be better.
Cool.
Arthur, do you have a take?
Are there any more like final takeaways anyone would want to make sure that you put out there? Anything you didn't get to mention um, before we sign off? And actually, we have a POAP. I don't want to forget that either. But this has been really interesting. I mean, I've learned a lot. I think we'll share all the resources that we've had too. I think I think it's Ben, you're sharing your screen. You've been popping open probably like 10 different tabs here showing things. So and yeah, I think hopefully we've been able to span kind of like the practical for validators, but also like the kind of strategy and theory behind all of this and how it's being developed technically. I feel like we've spanned a lot of different dimensions here, so it's been pretty cool. Remy, do you want to show? Oh, yeah, go ahead.
Sorry, I just going back to that question. I'd just like to highlight the L1 can do more. We know it can do more by changing, there's EIPs and so forth. So we're not trying to stress the validators. We're trying to improve how L1 works to still operate with the validators, which is why this data is very important that Sam mentioned, so that we know, how things are working. But yeah, that's sort of, we're making these changes with a lot of research, with a lot of cognitive knowledge of maintaining that decentralization and keeping the validators on board without stressing them.
So sorry, my internet disconnected me, but one point I would make about that question, well, two, I guess, the safety net for being able to eject an L2 and needing to absorb all of that onto the L1. We need a lot of space for that. The other thing is that's often not considered, when prices are really expensive, it stops a lot of people from being able to access this network. So by prices coming right down, it does enable people that might be in less advantaged places in the world to be able to participate in the network, which can only be a good thing.
Absolutely. When I look at the roadmap and some of the discussions around lean Ethereum, which seeks to address the criticism that Ethereum is too complex, right? That there's a lot of tail risk because it's such a complex network, and go and rip out complexity and remove tech debt. One of the things that was identified as tech debt, finally, is the thing we just put in which is blobs. So one of the ideas in lean Ethereum is rip blobs out again and go back to call data. That is only possible if we're actually at gigagas. And even then we'd have to do the math and the observation to see whether call data can accommodate layer twos, right? But I guess what I'm saying is these crazy scaling ideas give options. They allow Ethereum researchers to think about, can we radically simplify? Can we remove systems and go back to simpler ideas because we have the gas now to do it?
Yeah, that's fascinating. I mean, it kind of gets at like the whole like process of Ethereum core development and consensus and everything about how this winding path goes. So it'll be interesting to keep following and see, that side of things. And that's probably more like mid to long term future, right? If you're thinking that far ahead. Um, it's definitely fascinating. Is there anything else before we kind of close here that anybody want to mention, or this has been great though? POAP, yes. Let's do it, Remy.
It's on stream.
We're showing it. All right, cool. It's the same drill as we've done before. So we use this POAP airship tech, capability, and you can collect the cool looking POAP that we have here that is sign that you participated. So yeah, you just send 0.001 ETH to poap.ethstaker.eth, and it mints on Arbitrum. It's powered by Arbitrum. So they do sponsor us for that, and we thank them for that. But yeah, go ahead and do that, and we'll show that you were here. So thanks for sticking around, and for learning. I think, speaking for myself, I learned a lot from you all. So I appreciate the time and fielding all these questions. It's pretty cool. Lots of good work and great insights all around.
Thank you. Thank you.
Great. Thanks, everyone.
Cool.
Thank you.
All right.
Thank
Thanks.
you.